So good afternoon, everybody. Today we are going to see very important concept, that is procedure for part design. So if assume yourself as a manufacturer and some customer will come to you and customer will give you some drawing and it will be asked or some problem will be given to you. We want to make so and so component, so please supply these 10,000 components to us. Then how you will act as a manufacturer or how your design engineers will work, whatever may be the project you have received. Now, how the problem initiates. So in the earlier all classes, we have studied the number of parameters for part design. But as far as your syllabus is concerned, so you don't have to consider all these parameters in detail. So it is just introductory purpose only, how part is designed, that contents are added in the syllabus, not in so deep. Okay. So when exam is subjective, there is always in section 1 question, it was asked in all earlier question papers and it is part of the question paper. Design the XYZ component. For example, we are taking bush. Okay. Design the bush for so and so application, and application is given and it is explained. So and so is application, and for this application design your bush. So you have to decide how much weight that component will sustain, what is the strength of that component, which manufacturing or molding process you will use, then which material you are going to select, how you are going to give shape to your component, and how you are going to modify that component, and final drawing. These are the number of steps in the problem of part design. Now, I will tell you what type of questions may be asked. Design a bush for table leg. There is one table you have seen, the number of staff tables in the college, or you might have seen your liners in the lab. So every table or liner, it is having one bush fitted at the bottom side. I will show that to you here. See this bush. I hope everybody you are observing. So this is a bush which is fitted to all the 4 legs. Okay. In this way, these bushes are fitted to number of components, maybe the liner, maybe bench, etc. So this bush is to be designed by your side. There are a number of ways to design the bush. It may be hollowed, it may have some thickness, it may be screwed, it may be press fitted, it may be fitted with adhesive joint, whatever may be. Now, so if it is asked to design the bush for stool, then there will be 3 or 4 bushes. Sometimes there are 3-leg stools, sometimes there are 4-leg stools. Okay. Then sometimes the bush may be asked to design for only bench. So on bench 2 students are sitting. Sometimes the bush is asked to design for table. On that table nobody is sitting. Just table is used for putting some components. Then some old age man, the senior citizen, handling one stick, and that stick is having bush fitted at the bottom side of that stick. That may be single, or sometimes there are 3 or 4 legs to that stick also. Why I am telling this? Because all these illustrations were asked in the earlier examination. So how question is asked? Design a bush for a stick, or a stool, for a chair, for a table, for a liner, for a bench, whatever may be. Design a bush so and so, and that is having 4 legs, that may be having 3 legs, it may be explained. And then why? To avoid the skidding, to avoid the slippage, and assume suitable data wherever required. Then what information you require? The information required is the diameter of that leg. Initially, for making the problem very easy, we'll consider round diameter. So assume that it is a pipe. So table is made up of a pipe. It is having 4 legs. Design the bush for the pipe, bush fitted at the bottom of pipe. Diameter of pipe is 50 mm. Assume suitable data wherever necessary. So problem statement. Write down. Problem statement. Now I hope everybody is with pen and paper. Sometimes some calculations are also required, and I am going to ask to you that calculations because I don't have calculator with me. And that answer you have to give to me. Calculator means simple calculator, only mobile calculator is also sufficient. So problem statement. Design a bush fitted at bottom of 4 legs of table. The legs are made up of pipe of diameter 50 mm. Bushes are fitted to avoid the skidding. You can say laboratory table. Laboratory table. Assume the suitable data. Assume the suitable data wherever required. Assume the suitable data wherever required. Weight of table equal to 20 kg. Weight of table equal to 20 kg. So what is aim? Aim is to design the bush. Okay. Now I hope you are starting with me writing in the notebook. Oh. Excuse me. So I hope now you are starting with B, solution. Solution. Now listen. So there may be different constraint. So bush may be fitted with screw. Bush may be fitted with adhesive. Bush may be fitted press fit. Okay. Now, if we consider bush is fitted with screw at the bottom, then table base should be flat, or leg base should be flat. So this is the leg. Of the table. This is the leg of the table, and here you require to fit the bush, and then it may be screwed in this way. Screw is fitted so that bush will be locked there. We are going to design this bush. This is 50 mm. So bush diameter may be little less than 50 mm. It may be 30 mm around. That's why last statement is assume suitable data wherever necessary. So started with solution. So write point number 1. Point number 1. So I hope you are writing, because and one statement I want to make. Whatever problem may be asked, it may be asked stool, it may be asked stick, it may be asked bench, it may be asked table. You have to just concentrate on this weight and the diameter, and remaining procedure is same for all problems. So you have to understand it and mug it. Don't mug blindly. Okay. So procedure remains same for all the problems. Now, solution. Step number 1. Right? Bush, it is considered that bush is fitted with screw. It is considered that bush is fitted with screw and hence, and it is considered bush is fitted with screw and the leg base is flat. Leg base is flat. Hence, bush is to be prepared. Bush is to be prepared with hole at center. With hole at center. That is our constraint. Okay. So your bush should be with hole at center. Bush should be with hole at center. Now, next line. Step number 1. Step number 1. Selection of manufacturing process. Selection of manufacturing process. Selection of manufacturing process. Now, we have studied different manufacturing processes, which injection molding, compression molding, then extrusion molding, rotational molding. Now, bush is a very simple component, and always decide for low cost production, injection molding is the best process. So, step number 1, I am explaining selection of molding process. Selection of molding process. Write down statement. Bush design being low cost process. Bush design being low cost process, comma, injection molding will be preferred. Injection molding will be preferred. Okay. So step number 1, you have to remember, you have to write this statement that injection molding be prepared for this. Second is load distribution. On bush. Load distribution on bush. How it is calculated? So table is there. Table is having 4 legs. Weight of table is 20 kg. So you can divide that on each table. There will be 5 kg load. But the table you are not going to keep it empty. It is laboratory table. Okay. So assume that some 20 kg or 20 kg or 30 kg load you are going to put on that table. Let us take maximum. Let us assume that some 30 kg load you are going to put on that table. Right statement. Weight of table is 20 kg as given in the problem. See, it is given. Weight of table is 20 kg as given in the problem. And let us assume 30 kg weight. So we are taking maximum. Some machine may be there on the table. In some laboratory, I have seen some big machines are kept. And let us assume 30 kg load is kept on the table. Hence, load on each bush 20 plus 30 is equal to 50 kg. 50 divided by 4. So around 12.5 kg. Load on each bush is 12.5 kg. And now next step is important. Approximate bush dimension and bush material. Step number 1, remember this. Step number 2, remember this. Now step number 3. Approximate third step, approximate bush dimension. Approximate bush dimension and bush material. So let us assume bush material as a PVC. You can write the statement, let the material be PVC. Let the material be PVC. Okay. Next. So pipe is of 50 mm size. This is 50 mm pipe size. And you are going to fit the bush here in this way. Now, this bush, let us consider, here I already told, assumptions, it's based on assumptions. If one of the student will assume load of 10 kg on the table, so load per bush may be different. If you will just approximate load, if you consider 20 kg, load on each bush will be different. So as per the assumption of different students, some calculations may be changed. So let us decide common dimension for this bush. Let this bush be round, right? Let this bush be round with 30 mm diameter. Let bush be round with 30 mm diameter and 10 mm height. 30 mm diameter and 10 mm height. And that is having one hole inside. So I am going to draw the rough dimension of the bush. So solid initially we have considered. Let this be 30 mm. Draw this. So this is one plastic disc having one hole at the center. Initial design, one plastic disc with hole at the center. Why hole is required at the center? For fitting the screw. If that hole diameter, let screw diameter may be suppose 4 mm. Screw diameter. Sometimes in the problem, screw diameter may also be given. So if screw diameter is 4 mm, then here remaining is 26. So this is 13, 4, 13. These are the dimensions. And this is 10. This is figure 1. So in further or future references, I will say figure 1, etc. Figure 1. Draw this. Now this bush is going to bear the load of 12.5 kg. Right statement. this bush, it has to bear load of 12.5 kg. It has to bear load of 12.5 kg. Okay, then hence sigma is equal to load upon area. Let us calculate the stress, because we have selected PVC material. What we are doing now? Cross verifying. If this plastic disc we have considered as the initial design, round disc with center hole, and let us consider whether the strength it can sustain for this. Load upon area. Load is equal to 12.5 divided by area now. How to calculate cross section area? Pi by 4 d square minus d square. Pi by 4 30 square minus 4 square. Tell me this calculation now. Tell me this calculation. I will take name of somebody. I want this calculation. Just Sorry, there was some disturbance. So I hope by the time you might have calculated this. Who will tell? Please tell value of stress. What is the value of stress? Somebody put in chat box. Sonali Sawan, row number 3. Zero 0.018. Okay. 0.018, it is kg per millimeter square. So you can write 0.018 kg per millimeter square. And we have selected PVC material. And PVC material strength is around 40 to 50 megapascal. So which is good strength than this. So our material can sustain this load of 12.5 kg. Our material can sustain load of this 12.5 kg. You can write statement. Generally, material selected is PVC with strength 40 to 50 megapascal. 40 to 50 megapascal. Full stop. Considering more factor of safety, the above material is selected. Now, next line. So already we have studied that solid components are not permitted as per plastic design guidelines. So this, we are not going to use this solid block. We are going to make it hollow. Okay. So next step, step number 4. Step number 4, wall thickness. Deciding wall thickness. So write down statement. Solid components in injection molding. Solid components in injection molding will shrink and hence figure 1 is modified to. Figure 1 is modified to figure 2. As given below. Figure 2. Figure 2. So we have made it hollow now. We are modifying stepwise. Hollow bush. But it is very difficult to manufacture because there are horizontal shuts and sliding cores. Write down statement. The design from figure 2 requires sliding cores. Sliding cores. Hence, it must be open from one end, because now it is closed from upside and downside. It is like you have closed the cap on one flat. You have put some cap on some flat cylinder. Okay, so it is that like that, closed from both ends. So that we don't want. So it must be open from one side. To make it simple, comma, figure 2 is modified to figure 3. Figure 2 is modified to figure 3, considering bosses. So step number 5, boss in bush. Considering boss in the bush. In this way. This middle part is called as boss. In this boss, so you are going to fit your screw. Okay. So design is further modified by keeping it open from one end. Now you can manufacture this easily. Here this is difficult to manufacture. You can manufacture this clearly. Still, this boss is not having at the same level as that of edges, and parting line is little different. Write down the statement. So I hope you are writing every statement, because statement is important. Write down the statement. In figure 3, comma, parting line is not uniform. So you keep this height little more, then you can understand. Parting line is not uniform. Hence, figure 3 is modified to figure 4. Figure 3 is modified to figure 4, as shown in figure. They are at the same level now. Yes. So this is the boss. Now, this boss, there may be problem of flexibility of this boss. So it should be supported by something, and that is your rib. Yesterday I have told you. Figure 4. I hope you have noted it down and drawn it. I am modifying it from figure 1 to figure 2, figure 2 to figure 3, figure 3 to figure 4. One more small modification is remaining now. Write down the statement. As the boss at center becomes flexible, it requires some support. It requires some support, which is provided by ribs. Which is provided by ribs. Sixth, rib design. Now, imagination is required. Assume one circular round cylinder, or assume one cylinder open from one end. The cylinder is having less height and more diameter. I repeat once again. Assume one cylinder with more diameter and less height, and at center there is this boss. So that require some support. So at 90 degree each, the ribs are provided. So for example, if this is the top view, this is the top view, this is boss in between. So ribs be provided like this. In this way. Ribs be here in cross section it is not possible to see, because this itself will act, if you draw the line here, that will act as a rib. So ribs are nothing but vertical walls provided, which connects the circumference of the bush and the boss, as shown in here. Write down. To provide the support, to provide the support to the boss, four vertical walls, that is ribs, four vertical walls, that is ribs, are located at 90 degree apart. Are located at 90 degree apart. Are located at 90 degree apart. Okay. In this way, ribs are giving support to the boss. So here we can't show it, that's why I have drawn top view. Then 7, allowances. Allowances. Write down. Considering shrinkage and draft allowance, the final bush drawing, is modified to, this is figure 4, this is figure 5, figure 6, as given below. So I will provide little table to this. See here, I have provided the taper here. Now tell me, what is the base size which we have considered earlier? This base size is 30 mm. 30 mm remains everywhere same. Here there is little change. If you keep this base size as a 30 mm and if you provide the taper, then this will be decreased. Yes or no? Then how to calculate this? This is angle tan theta. This height is 10 mm. Then you have to find out this distance x. You have to find out this distance x. How much size is pressed from bottom side? How to calculate? Tan theta is equal to x by 10. X is equal to 10 tan 2 degree. Here usually 2 degree taper is provided. 2 degree taper is provided, and whatever dimension is coming, that will be reduced from 30 from both the ends. So approximately, so if you consider approximately dimension reduced maybe 1 mm, it may become around 29 mm. This is 30 mm. So we have considered 0.5 reduced from both. Let this x value may be 0.5 around. Just check what is it. It will become 29 mm. This is your figure number 6. So you are almost at the end of your bush design. And how we are going to locate it, finally, that will be shown in the last figure. Next line. You have to write all these dimensions here, 29, 10, 30, because this is final drawing. The final layout of the bush, with front view and side view located in the mold is as given below. This is your mold. In this way. This is another half. Here ejector pins are provided. And you can remove this in this way. This is the final bush which you are going to design and manufacture in 5,000, 10,000 quantities so that you can supply it to the customer. So I repeat once again now, starting from step 1. Any problem may be asked. Chair may be asked, table may be asked, stool may be asked, stick may be asked. You have to follow all these steps and you have to draw all these figures, figure 6 and figure 7. So remember these 7 figures, steps. You will get 6 marks in case of subjective examination. Okay? And you should know how parts are to be designed. So starting from selection of manufacturing process, selection of material, then calculation of the stress, deciding the load, then we have started 1. In the figure 1, some initial block is considered round disc. Then there is a center hole. So it is solid parts are difficult to manufacture. That's why we are making it hollow. So after making hollow, it is difficult to mold. That's why we have modified the design to figure 2, 3, 4. And considering the supports, we have considered the rib. And this is the final step. So I hope you understand this. All these concepts. If any doubt is there, you can ask me. You can see this video once again, which I am putting on the link. Okay. So this is all about design of bush. Here, this is the end of unit number 4. And that is section number 1. Okay. Now, next class, we are going to start with section number 2. I hope you understand this. Just wait for 1 minute. Okay, thank you. We will stop here.